Hi, welcome to Water Treatment Training at watertreatment.training. As you go through this course, I'll help you understand the role of each module in the water and waste treatment methodology. Let's begin with what this course is all about. Water and wastewater treatment involves treatment of influent water and wastewater, and the setting up of control measures to maximize the effect of treatment programs and to maintain safe surroundings. This course will help you understand the process of treating influent water and wastewater, and the treatment programs available. It is important to understand the basic concepts related to water and waste treatment before moving ahead in the course. This general technology module will introduce these basic concepts and be the foundation for the complex information on specific treatment programs and control measures that will follow later in the course. This module will help you answer questions like, what are the treatment programs and product range available? How is particle stability a barrier to the separation of contaminants from wastewater? What are the various types of coagulants? What are the various types of flocculants? What are the various polymer Makedown processes? What are the process steps to perform a jar test? What are the mixing characteristics of coagulants and flocculants? Now, I will be introducing you to the first topic of the wastewater treatment series. Here, you will learn about the reasons for treating influent water and wastewater. This will help you understand customer requirements and offer solutions from the various treatment programs. After completing this topic, you will be able to list the treatment programs and product range that you can offer to your clients and customers. First, we need to know what is the definition of influent water, wastewater and effluent water, as I will be using these terms a lot during the course. Influent water is essentially all the water that flows into the plant, to be used in its industrial processes. Influent water may come from town's water, underground bore water, or river water. It may come from anywhere, but it has to meet the purity specifications before use. Wastewater, on the other hand, is all the water that has been used by industries for industrial operations. This water is usually highly contaminated and contains high levels of dissolved or suspended matter. Wastewater needs to be treated and purified to meet the safety regulations before it is discharged into sewage and streams. This discharged water can otherwise be called effluent water. There are many reasons to which we need to treat water and wastewater. Firstly, it is to have good quality influent water. Many industries requires good quality influent water to avoid contamination with the processes and to avoid process equipment damages. Influent water must be treated to remove impurities before used in industrial processes. Industries, especially those manufacturing microelectronics, require good quality influent water to avoid contaminating the silica wafer crystallization process. The contamination may cause rejection of the silica crystal, leading to wastage. After water has been used in an industry, impurities in the wastewater must be removed before the water is discharged. This treated wastewater is the effluent water, which must contain no more than the permissible limits for impurities before discharge into a river or stream. Without proper treatment, the wastewater will pollute the water body it is discharged into. Typically, petrochemical plants have their own wastewater treatment plants to treat water contaminated with hydrocarbon and chemicals. Before discharging the effluent water into a river or a stream, this wastewater is generated during the petrochemicals processes and contains high levels of hydrocarbon and chemicals. Many of these substances are toxic, poisonous, or even carcinogenic. Without proper treatment, contaminated water will harm marine life and eventually affect all life forms. There are also situations where wastewater is treated not only to a quality that is safe for the environment, but to a higher quality that is fit for reuse by the manufacturing processes. This enables the manufacturing plants to conserve water by reusing the treated water. In some countries where the price of water is high, industries are driven to look at some new ways to conserve and recycle wastewater. One example could be of a petrochemical factory in Middle East, where water resources are scarce. It is important to recycle the wastewater to ensure continuous running of the plants at the desired capacity. In certain industries, the contaminants in the wastewater are high-value materials, for example, the gold in wastewater from the gold plating plant, or the oil in the wastewater from oil refineries. It makes sense to recover as much of these contaminants from the wastewater stream as possible. If these precious materials are not recovered from the wastewater, high wastage may occur and profitability could suffer. The wastewater treatment processes can help achieve that objective as well. There are mainly three types of contaminants in wastewater. These are suspended solids, dissolved solids, and colloids, in which we deal each one differently. Now let's learn about each contaminant in detail. Suspended solids are particles that do not dissolve in water and can be viewed by the naked eye or through an ordinary microscope. Suspended solids make water turbid. They are captured during gravimetric analysis on a 0.45 micron filter. The examples of suspended solids in water include mud, clay, silt, and microbiological material. They contribute to turbidity and can be removed quite easily by using physical or mechanical means, such as sedimentation or filtration. Dissolved solids are particles that are naturally soluble in water and cannot be removed by processes such as filtration. The examples of dissolved solids include sodium and potassium salts, and chlorides. Dissolved solids is a measure of total amount of dissolved matter, determined by evaporation. Various softening processes such as lime softening and cation exchange via hydrogen zeolite will reduce dissolved solids. Colloids are dispersed particles that are not visible under ordinary microscopes, and are only visible under high-powered microscopes. They contribute to turbidity and are largely responsible for the color of natural water. Colloid particle sizes range from 1 to 1000 nanometers, and have such large surface areas relative to their mass, that gravitational forces do not influence their suspension. The examples of colloids include paint, milk, and ink. Now that you know the various types of contaminants in wastewater, let's have a look at a variety of general treatment program technologies. These include, but not limited to, influent water clarification, wastewater treatment, sludge dewatering, foam control, oil recovery, and odor control. Influent water clarification uses processes such as coagulation, flocculation, clarification, and filtration. Influent water clarification ensures that influent water meets purity requirements before it can be used in an industrial process. Coagulants and flocculants are commonly used to aid the clarification processes. Similarly, coagulant and flocculants are typically used to improve the efficiency of the sedimentation and flotation processes. Wastewater treatment also commonly involves removal of heavy metals carried out by using chemical products. Sludge dewatering is a process to remove water from sludge. The resulting solids can be disposed of in landfills. Polymers can be used to improve the dewatering efficiency and reduce the sludge volume significantly. Foam control treatment can be done with foam control products. Commonly used agents are insoluble oils, polydimethylsiloxanes and other silicones, certain alcohols, stearates, and glycols. Oil recovery can be done with coagulant polymers, and recovered oil can be dehydrated with emulsion breaker products. Odor control treatment can be done with non-amine-based organic sulfide scavengers and inhibitors, to inhibit the reduction of sulfur compounds such as hydrogen sulfide. This completes the topic of Introduction to Water and Waste. Here is the summary of the key points. We now have reached the end of Introduction to Water and Waste topic in the wastewater treatment series. Thank you for listening and watching this lecture. If you would like to see other courses, please visit watertreatment.training.